Hello students, this is Niteen Mohod, and through this video we are going to learn about pin diagram of ATmega32A. ATmega32A is a 40 pin IC as you can see in the diagram. This is a DIP package, that is dual inline package, where half of the pins are on one side and the remaining half on the another side. So it's a 40 pin IC with 4 8-bit ports. So these ports are port A, port B, then port C and port D up to this. So that's why it can connect 32 digital inputs or 32 digital outputs with this microcontroller. Most of these pins can be used as input or output or dual purpose pins. Moving on to pin number 1, which is XCK, that is external clock. It applies external clock to UART module inside ATmega32A. So the UART module which is inside this ATmega32A, to that UART module the external clock is provided through this pin, while T0 and T1, that is pin 2. So T0 is this, which is the alternate function of pin number 1, and T1, that is pin number 2, are used as an external counter to count external events outside the ATmega32A by connecting a sensor at these pins. So externally sensors can be connected to these pins T1 and T0, and the external events can be counted with the help of these pins. Pin number 3 and 4, which are AIN0 and AIN1, that is 3 and 4, AIN0 and AIN1. These are the analog input pin 0 and 1 respectively. It provides inputs to the comparator inside IC for the two analog inputs at pin 3 and 4. So inside this IC at pin number 3 and 4, the comparator is there, that is the operational amplifier is there, and the inputs of those operational amplifier will be connected to pin number 3 and 4, which will act here as a comparator. Alternately, it works as external interrupt pin 2 along with external interrupt pins 0 and 1, as you can see in pin number 16 and pin number 17. So this is the interrupt 0 pin and interrupt 1 pin, and interrupt 2 pin is here at pin number 3, through which the microcontroller can be interrupted by the external peripherals or devices. And under this situation, the microprocessor stops whatever it is doing and attends the interrupt or attends the device through interrupt. Then pin number 4, that is OC0, which is output compare 0, where 0 stands for timer 0 actually. With the help of the timer, PWM, that is pulse width modulated waveform, can be generated, and pin 4 can be used as output pin to generate pulse width modulated signal. Pin number 5, 6, 7 and 8, as you can see here, these are the serial peripheral interface protocol pins, which is also called as SPI protocol pins. These are SS stands for slave select, MOSI, that is master output slave input, then MISO, that is master input slave output, and SCK, that is serial clock. These pins not only allows to load the program in ATmega32 ROM locations with the help of AVR programmer, but it also allows external peripheral to communicate with ATmega32, provided one condition is there, that the external peripherals also supports this SPI protocol, means the external device which requires to have communication with this ATmega32A must have these pins with it, so that there should be a communication between the device and the ATmega32 microcontroller. Pin number 9 is a reset bar pin. It's an active low pin, and on connecting it to ground, it resets ATmega32 and PC, that is program counter, will be initialized to 0. Thus, now The program will be executed from 0000 and all RAM locations will be cleared. And all the ports PA, PB, PC and PD will be defined as an input ports. Pin number 10 and 11, they are VCC and ground pin. These are actually the power supply pins requiring plus 5 volts power supply. Then pin number 12 and 13, that is crystal 2 and crystal 1 pin, which provides external crystal frequency of maximum 16 MHz to ATmega32, beyond which the ATmega32 doesn't support. ATmega has its internal on-chip clock also. Pin number 14 and 15, which are actually the RxD and TxD pins, receive and transmit data pins, also called as UART protocol pins. Through these pins, microcontroller communicates with the peripherals supporting this UART protocol, and in this case, RxD pin of the peripheral will be connected to the TxD pin of the microcontroller, or TxD pin of the peripheral will be converted to RxD pin of the microcontroller. Pin number 16 and 17, which are INT0 and INT1, these are the external interrupt pins like INT2 as we have seen here in pin number 3. On receiving interrupt signal on any of the pin, microcontroller holds and go to the respective allotted subroutine address. See, here the specific address, subroutine address, is allotted to each interrupt pin, and therefore accordingly the microcontroller will hold and go to the respective allotted subroutine address, and on executing subroutine it will returns to resume the main program. Pin number 18 and 19, which are OC1 and OC1A, that is OC1B and OC1A pins. It will deal with the timer 1 and generates pulse width modulated signal with the help of timer 1, which is a 16-bit timer. Pin number 20, which is a ICP, is an input capture pin. It calculates the frequency or time period, because frequency and time period having the relation of inversion, that's it. Frequency is equal to 1 upon time period. So input capture pin will calculate the frequency or time period of the unknown signal provided to this pin. Pin number 21, that is OC2, this one. So where 2 stands for timer T2, with the help of this timer, pulse width modulated waveform can be generated. Pin number 22 and 23, that is SCL and SDA pins. It follows I2C, that is inter-integrated circuit or two-wire interface protocol. It uses serial data and serial clock pins, where the data is transmit or receive at a time through SDA pin, and since it can either receive or transmit at a time, it lowers the speed, while the clock is provided to external devices by the ATmega32 through SCL pin. Pin number 24, 25, 26 and 27, that is TCK, TMS, TDO and TDI, they comes under the JTAG communication. These pins are the test clock, test mode select, test data output and test data input pins. JTAG communication is used for an on-chip debugging of ATmega32, that is, while microcontroller runs, we can check the internal status of all the registers. Also, this JTAG protocol helps to load the program in the flash memory of ATmega32. Pin number 28 and 29, as you can see here, which are TOSC1 and TOSC2, is a timer oscillator 1 and 2. It used to run timer 2 on external clock, for which external crystal needs to be connected between pin 28 and 29. Timer 2 can also be run on internal clock of ATmega32. Next is pin number 30, 31 and 32. that is AVCC, G and D, and A reference pin are dedicated pins for internal analog to digital converters of ATmega 32. ATmega 32 has 8 10-bit internal analog to digital converters, thus can connect 8 analog sensors with it. Ground and AVCC pins are used to power up internal ADCs, while A reference is ADC reference voltage. Hence, if 5 volts are given at this pin, then the microcontroller only accepts 0 to 5 volt analog voltage. Then pin number 33 to pin number 40, that is port A pins, you can say, where the pins you can see ADC 7, ADC 6, likewise ADC 0. As said above, ATmega contains 8 ADCs as above, and thus one can connect 8 analog sensors to it. Hence, on receiving data, internal ADC will convert it into 10-bit equivalent digital code, and finally the digital data can be used in the program. So I hope the pin diagram of ATmega 32A and the importance of all these 40 pins is clear to you. Thank you.